Hi guys, hope you're doing well. Welcome to my channel. Today I'm talking about the brain. About the brain, we have so many things that people don't know about the brain, and I'm going to start with the most basic ones. Why young brains are so flexible. And before I do that, I'll just compare the brain of baby animals and that of baby humans. Why animals are born with the ability to walk maybe after some seconds or some minutes, but human beings have to take like maybe 9 months for you to be able to walk. So the brain of animals and the brain of humans have a difference, and some baby animals are born swimming. For example, dolphins. Some are born and can run after some minutes or hours, like baby zebra or the calf. So this clearly tells us that they are totally independent right from birth, and they are different from human brains. So I am going to explain why this happens. This is because the neurons of the baby animals are wiring up in a pre-programmed routine. Their brains are pre-programmed, so they are born with prearranged brains, unlike human brains, which are born unfinished. So the animals, they are genetically pre-programmed brains for certain instincts, like walking. But humans also have pre-programmed brains for specific behaviors like crying or smiling. But majorly human brain is shaped by life experiences. That is why you are born, you can't talk, you can't walk, you're helpless, and you totally depend on your parents. And that brings the question, why are young brains so flexible? Why is it that when you take a child to learn a new language by age 4 or 7, they are able to learn that language faster than when you take them when they are 20 or 30? So human brains, when they're young, they are so flexible. And many people think that the children have brain cells that are still growing, but that is not the case. The brain cells are not growing. In fact, the number of brain cells in adults and children are the same. So the only secret here is how the brain cells are connected. The connections of brain cells in children and adults is totally different. The neurons in a baby are unconnected. They are not connected. When a baby is born, they are born when the neurons are unconnected. So in the first 2 years of growth and development, they start connecting so fast, and 2 million synapses or connections are formed per second in a child's brain. So this explains why their brains are so flexible. They are born with neurons which are unconnected, and in the first 2 years, the neurons connect up so rapidly that they have 2 million synapses per second. And this means that by 2 years, they have 100 trillion connections. 100 trillion. You can imagine that. 100 trillion synapses or connections. And this is double of what adults have. So they have so many connections during infancy, and that is why their brains are so flexible. They can learn things so fast. So at this age also, the connections have reached their maximum. They can't go beyond 100 trillion connections. Synapses can't go beyond 100 trillion. So they have reached their maximum. Hence, what now begins to happen is called pruning. Because the connections are too much, now we start to prune and only remain with the ones which are relevant for everyday life, or those which have been hardwired. So as they grow, around 50% of the synapses are paired back. The connections that are useful are paired back, and the only synapses that are pruned are the ones that are not useful. The ones that are not useful are pruned. So the ones that remain are the only useful connections. So in other words, you become who you are because of what is removed in your brain and not because of any kind of growth in the brain. Yeah, I'll repeat that. You become who you are because of what is removed from your brain and not any kind of growth in the brain. Yeah, the synapses that are not useful are pruned off, so you only remain with those that are useful or relevant for the daily activities that you partake in. So for example, when your first language is French or Japanese or English, when you are young, you are exposed to this language from childhood, then your ability to hear particular sounds in that language is refined because it is introduced to you when you are still young. So your ability to hear particular sounds in that language is refined, and this worsens your ability to hear sounds from other languages. So let's say you are born in France, then you are raised in New York. So that means you are born and the first language that you were exposed to is French. So during the early years of your life, you'll be able to hear particular sounds in the French language. But then when you are raised in New York, you will forget the ability to hear particular sounds in French worsens, and your ability to hear sounds in English are improved. So that is how it works. So we are therefore sculpted by the world we happen to drop into. We are sculpted by the world we happen to drop into. Good. So generally we are born hardwired with some abilities. We are born hardwired with like crying, with abilities like crying, smiling, and the ability to learn the native language, your native language. Humans are born with the abilities to cry, to smile, and to learn your native language. That is just a few examples. So unlike animals, our brains are not pre-programmed. The brain is shaped by life experiences, and the synapses that are not required are pruned off. So the next thing I'm going to talk about is a situation that is called mirroring. Mirroring. So this mirroring is a situation whereby, let's say you are given a picture of a person crying, or you are given a picture of a person smiling. You'll find yourself smiling. And why? It is called mirroring. Use your facial muscles to copy the expressions that you see. Yeah, you copy the expressions that you see. And this explains why couples who have lived for a long time begin to resemble each other in a way. Not that they look exactly alike, but they begin to resemble each other. It is because of mirroring. So what happens is this: when your spouse is happy, you're happy together. When your spouse is sad, maybe they are sick or someone that is dear to them died, then you are sad. All of you are sad. So what happens is you mirror each other's facial expressions, that the pattern of wrinkles begin to resemble each other, or in other words, you start to look the same. You mirror each other. You mirror each other's facial expressions, and when this is done, the pattern of wrinkles begin to resemble each other. And when the pattern of wrinkles in the face begin to resemble each other, then you start to look alike. So you begin to resemble each other. This explains it in a layman's term. Yeah. Then I'm going to talk about a cosmetic procedure that many people are into nowadays, mainly because of old age. People don't want to have wrinkles, so they go for what is commonly known as Botox. So the scientific name of Botox, actually Botox is a toxin. That is what people don't know. It's a toxin that is injected into your facial muscles so that it reduces wrinkling. So Botox is actually a toxin, and if many people knew it is a toxin that is being injected into them, I don't think anyone could have agreed to that. So Botox is actually called botulinum toxin. Botulinum toxin, familiarly known as Botox, and what it does to disable wrinkling, because people don't want to have wrinkles here despite your age, so you want to look young forever. So what Botox does is it paralyzes facial muscles, so your muscles are paralyzed. You can imagine when your muscles are paralyzed, then this means you will be very poor in mirroring. You want to be able to correctly mirror expressions that you see. And this experiment has been conducted in many labs, scientific labs, by neurosurgeons or neurologists. Neurologists have done this experiment, and they have found out that people who have been injected with this Botox, they are very poor in mirroring. They can't copy expressions they see. And not just that, they are also very poor in understanding people's facial expressions, because themselves they can't express their facial expressions fully. So Botox has paralyzed their muscles, and therefore the side effects are not widely known. That is why many people end up using Botox. So it makes you unable to identify emotions on pictures or faces. Maybe you are talking to someone and they're smiling at you, but you're just looking at them. You can't identify, not that you're blind, you can't identify the emotions in a face correctly. Because there is a lack of feedback from the facial muscles impaired by the Botox here. So there is lack of feedback from the facial muscles, and this impairs the ability to read other people correctly. I hope next time you are growing old, as you becoming a grandmom or a grandfather, you don't go for Botox. This is a toxin. It paralyzes your facial muscles, and I don't know why people love this. Just to grow old, it's a blessing. So the next thing I'm going to talk about is empathy, how it's connected to the brain. Empathy is putting yourself in the shoes of another person. When they are sick, you feel their pain. So empathy activates the pain matrix in the brain. That is the simple term that I'll use for that. Empathy, when you watch someone in pain, this is the thing. Watching someone in pain and being in pain uses the same neural machinery. When you yourself are in pain, or when a friend of yours is in pain, you seeing that or you being in pain, in the brain, the same neural machinery is used. So we are going to call this neural machinery the pain matrix. So this means when you see a person in pain, you can simply tell yourself that, it's their issue. But your brain or your neurons, they can't tell the difference. Seeing someone in pain and being in pain activates the same area of the brain called the pain matrix. And that is the basis of empathy. That is why you are able to empathize with someone. That is why you are able to feel their pain. That is why you go watch a movie and you cry because the characters are crying. You know very well they are acting, but when you see someone in pain and when you are in pain, to the brain it's the same thing. There is no difference. So it activates the pain matrix in the brain. So on the side of a person in pain, you can feel their pain through empathy because of what your neurons allow you to do. So the question that we remain with is this: Are our brains dependent on social interaction? Are our brains dependent on social interaction, or do we need to interact with others 24/7? Like, what happens if the brain is starved of human contact? When you are put somewhere with no humans, let's say in a cell or solitary confinement where you have no human contact, you are alone, let's say for 4 years, you only have a 30 minutes break every day to take your tea with others, and then you're back to your cell alone, one person. What happens to the brain when you are starved of human contact, when the brain is starved of human contact? Have you ever thought about it? Well, this is so interesting circumstance, because the brain, it suffers for a very long time when it is starved of human contact, and when it has no social interaction. So the pain matrix that I talked about in the basis of empathy in the brain, the pain matrix becomes active, and mostly people who are starved of social interaction, they start hallucinating, or they suffer from depression. They are depressed. So this is because the pain matrix in the brain is activated, and the brain suffers when for a very long time there is no social interaction. Let's say you are put in a solitary confinement for a long period, and this means that you are deprived of social interaction, and for a long time, you are denied social interaction for a long time. So this is so significant to the brain that it hurts literally. To the brain, it hurts literally, and this, we call it social pain. For example, let's say you are in school, you are playing netball, or you are in school and your friends are making stories. They are making stories, they're laughing, but when you join them, they keep quiet. They don't want to involve you in their story. You, on the outside, you just feel bad. Then you tell yourself, it's okay, if they don't want me to be in their group, then I'll just create something for myself. In the brain, an area that is activated is the pain matrix. So it causes social pain that it literally hurts to the brain. Like being excluded, it activates the same brain region as physical pain. So when your friends avoid you, then you may think it's just normal, but your brain is suffering, and the same area that is activated during physical pain is what is activated during social pain. So I thought that was really interesting, and I'm now going to give you an example of a woman who has been confined for 410 days in an isolated cell. Let's call her Emily. So she used to say, and I quote, she said, in the early weeks and months of solitary confinement, you are reduced to an animal-like state. I mean, you are an animal in a cage, and the majority of your hours are spent pacing. And the animal-like state eventually transforms into a more plant-like state. Your mind starts to slow down and your thoughts become repetitive. Your brain turns on itself and becomes the source of your worst pain and your worst torture. I'd relive every moment of my life, and eventually you run out of memories. You've told them all to yourself so many times, and it doesn't take that long. So she also says, the sun would come in at a certain time of the day at an angle through my window, and all the little dust particles in my cell were illuminated by the sun. I saw all those particles of dust as other human beings occupying the planet, and they were in the stream of life. They were interacting. They were bouncing off one another. They were doing something collective. I saw myself as off in a corner, walled up, out of the stream of life. End of quote.